Okay, now we're finally at the circuit build for our 3220 point breadboard project. I have some of the components sitting out here and some of my tools ready to go. And I think what I want to start out with is the LEDs. And the reason why I want to do that, because I decided I wanted to attach some wires at the ends of the terminals. I have a red LED right here, and I wanted to add some wire at the end of the terminals because if you remember on our box here, after we set everything up, and these are where the LEDs are going to go, these little panel mount LED holders. But because it's so spread out, and I'm going to have the circuitry placed inside the box somewhere, I don't know where yet, I need that length to reach. Let's say if the circuitry was going to be here or here somewhere, I need that length to reach to all the points where the LEDs are going to be. So I'm going to go ahead and prepare the LEDs with wires, and I'm going to use different colored ones since we're using different color LEDs. By the way, like I said, I have some of my components sitting out here, and I like to use these, what are they called, diamond painting trays. You know, if you're someone who does diamond painting or know someone who does diamond painting, uh, they always usually come with these little trays to put your little quote diamonds in. But I like to use them to put my components in. That way they're not, scattered all around the workbench here. But anyways, right now I'm working with the red LED. So I want to take some red wire, and I'm just going to say let's do about 8 inches worth. I want to give myself plenty of slack to, I got to get my cutters, but I want to give myself plenty of slack to be able to reach around to all the points. So I'll just say 8 inches sounds like a good enough length, maybe. You know what? Now I'm thinking I might want to go a little longer in the wiring because it's just like in building or construction, you'd rather cut your piece of material a little longer than shorter because you can always trim it off. So what I say 8 inches earlier, let's go 10 inches. So I'll go about 10 inches. I want to give myself a little bit extra slack. So 10 inches sounds like a safe length to me. And I can reuse that wire that I cut earlier for something else. So I'm going to strip the end. I just need a little bit, about 1/8 of an inch or so. Give it a little twist. And what I'll do is I'll go ahead and tin. I think this wire is already pre-tinned, but I'm not sure, but it's not going to hurt anything to go ahead and tin it again. So I want my red wire to be on the anode lead of the LED, and that's this lead here. So I don't want to put it at the very end because I don't need the whole length of this lead. So I'm probably gonna connect it further closer to the LED itself, so I can just trim the excess lead off later. And I'll go ahead and try to make this connection here. Okay. And what I'll also do is I'll put a heat shrink tube on there later. But now I'm going to use a black wire for the cathode lead. And again, I'm going to go ahead and do 10 inches. And this end's already stripped. So I'll give it a few twists. And I'll tin the lead, making sure I'm not touching anything with the iron. I think I was. I'm going to flip this over. I probably should just go ahead and snip it off, but I feel better not doing that until after I put the wire on there. So I need to tin the lead a little bit here. And then I'll place the wire on, like so. So now I have the two wires on to the two leads, and I'm going to go ahead and snip the leads off where are the excess leads. So I don't need that. So I accidentally burnt my alligator clip there. So it's going to look about like that. Now I need to get some heat shrink tubing. And I just need enough to cover what I just did. So let's see, I'll cut, let's say half of it. I'll put this back on the alligator clip. And I'll put the red heat shrink tube on, the red wire. Take it off so I make sure it goes all the way to the end. And what I'll do is I'll just hold on to this wire there. And I'll get my heat gun. I just thought of something before I put it all on there, before I heat it. I kind of want to cut this a little shorter because once this tube heats up, it's going to be kind of stiff, and I need all the room I can get inside the box. So I cut just enough to fit over that exposed lead and wire where we soldered at. That way I don't have too much tubing there. I can give myself some extra space inside the box later when these LEDs are going to be sticking down inside the box. So it looks about like that. What I'll do is I'll trim a piece of this black heat shrink tubing, and I'll do the same thing. I'll heat shrink some tubing on to the cathode side of the LED in that exposed lead there. And then I'll have this red LED prepped and ready to go for installation for later in the build process. And I'm going to do the same steps for the other LEDs. We still have a green one, yellow one, blue one, and a white one to do. I'm going to do the same process for each of those. And I'm going to use matching colored wire for each one of them for their anodes. And then I'll use black wire for all of the cathodes for each of the LEDs. And you'll see that here in a minute. I'm going to go ahead and do all that prep work for the LEDs, and then I'll come back with everything finished, and then we can go from there. Okay, now I have all of the LEDs prepped up. I have all their color-coded wires and heat shrink tubing on, so they're set and ready to go for later. For now, I'm going to just set them aside, and we'll go ahead and start work on the PCB board now and putting things on here and soldering everything together. What I'm going to do, well, first, let me tell you, I'm using, I think it's a 4 centimeter by 6 centimeter PCB board. It's just kind of your generic run-of-the-mill PCB, but it's a 4 by 6 centimeter. And I forget how many through holes there are on here, but sometimes it can be a little intimidating when you get one of these and you're looking at it. You've set up your prototype for your circuitry and you're ready to transfer your components to the PCB board, and you have no idea where you're going to put anything. It's not the same as putting components on a breadboard. So what I do, which makes things a little easier, is I'll go on to like a graphics design website, something like Canva or something like that, like a free website, and I'll create kind of a 2-scale setup. I'll just make it the whatever bread or whatever PCB I'm making, I'll make a quick design of it to scale, and I've even put the lettering as it is on this PCB board and the numbering, and I'll put the exact same amount of holes that are on the PCB board that I'm working with. In this case, this is the upscaled 4 by 6 centimeter PCB board here. And what I'll do is use this and print it out, and I will make all my markings in pencil and decide where I'm going to lay out components on the PCB board on paper. And you can see here, all I did was tape another sheet of paper on here to give myself extra space to make notes and kind of decide where everything's going to go based on the PCB, or based on the prototype breadboard that we did, and based on the circuitry. Again, all of this is available at mottbots.com under this project for the DIY 3220 point breadboard. But I'll refer, I print these off, and you can print these off yourself as well. I print these off and I'll kind of set them aside, and I'll refer to this on how I'm going to place components on there. You can kind of see my note taking and marking and stuff like that, and the components I'm using and where I'm going to put it. And the through holes I shaded where I'm going to put everything. So you can print this out yourself at mottbots.com under this DIY 3220 point breadboard project, and you can print one out yourself. It's for this particular PCB board, and you can mark yours up if you'd like to. You can change how you want to lay out your components on yours. You don't have to lay it out like I am going to, but I have this set off to my left here, and I'll be referring to it during the entire process of putting the components or soldering the components onto the PCB board. So the first thing I'm going to do is I'm going to grab my PCB board holder, and what I'll do is I'll install this on here, and the first thing I want to put on here is put these screw terminals on, and I'm going to use these as an easier way to make connections on the board. I'm going to use these 4 screw post terminals, and I'm going to place them on the far outside column of through holes here, and I'm going to place one of these 4 screw terminal or one of these 4 screw terminals on the far end, and I'm going to place another 4 screw terminal on the other side, in this case the left side, the far end of it. And I'm also going to use, actually I want to put these 2 side by side. It doesn't really matter, but in my notes and drawing there on the printout I just showed you, I have the 2 4 terminal or 4 screw terminals set side by side, and I'm using another 2 terminal or 2 screw terminal right next to that one. So it's going to look like this, and I have the screw terminals facing towards the board inside, so they're all right here, and I'll make all the connections on this side. And then what I'm going to do is I'm going to place another 2 screw terminal on this end, but this time I'm facing the screw terminals outward or away from the PCB board, like so. And then I'm going to skip, I think, 2 holes, place another 2 terminal or 2 screw terminal connector here, and I'm also facing the screw terminals away from the board. And all of them that I'm putting on this side, they're all going to be facing outward. The next one is another 2 screw terminal. Again, I'll skip, I think, 2 holes like so. And then finally, I'm using a 3 screw terminal facing away at the very end, like so. So it'll look something like this. Get a little closer. It'll look something like this. And what I'll do next is I'll just solder all of these on. I can actually set this down because it'll rest perfectly. I'm going to move this out of the way. But then I can solder all these points on here. And then once once you've seen someone solder or soldered yourself, it's not really necessary to have to sit here and watch me do every single one of them. So I'll pause the video and I'll solder all these connections up real quick. Then I'll show you what it looks like, and then we'll move on to the next components. Okay, now I've finished soldering these screw terminals onto the PCB board. That's done. So now I'm going to move on to placing other components onto the board. So if we refer back to my plan on what I'm going to do, I'm going to work from left to right and start placing the components on where I want them to go. Again, you don't have to do yours exactly like mine, meaning you don't have to set up your board in the same layout as mine, but you do, of course, have to, place your components exactly like we did for the prototype breadboard version, or even the schematic for the power supply right here. So you do have to follow how things are connected, but you don't have to follow like I'm laying my stuff out on the PCB board, because whether you're using the same board as I am, maybe you're using a bigger board or a smaller board, your layout could be a little different than mine. This is just how I'm planning to do mine. But what I'm going to do now is connect the components onto my PCB board, making sure I'm following the schematic and my drawing, and I'll put them on. There's not really any need to watch me put everything on, especially if you're not laying yours out exactly like mine, but I will pause the video and put everything on here to save some time for you, and then I'll come back and show you how everything looks, and then we'll go from there. Okay, I've got all these components set up here. So here, let me do this. I'm gonna put this back on here, and I'll just zoom in. So I have the components on here. I have it all soldered up, as you can see on the bottom. And let me just kind of explain what's going on here. So this part right here is my ground rail. I just took a piece of bare wire and soldered it across all these pins, and these pins are these screw terminals here. These screw terminals are my common ground. This whole side of the board here is my common ground. So if we refer to the schematic and stuff, we can see that we have points for our grounding in these areas, and that is our common ground here. We can see that in the printout drawing I did. I'll have to zoom back out a little bit. But these right here represent the screw terminals on the board, and all my grounds go to that common ground. So you can see the one thing that you can immediately see are the two voltage regulators. Let me tilt it a little bit. This is the L7806, and this is the L7809 voltage regulators. And then you can see the capacitors on both of these two voltage regulators. There's a 0.1 microfarad and a 0.33 microfarad. So the 0.33 microfarad is attached to the input pin of each of the voltage regulators, and then the other end, or the other terminal for the 0.33 microfarad, is attached directly to the ground terminal of the voltage regulator. That's the same for both regulators, and also the same for both regulators are those 0.1 microfarad capacitors that one pin or one terminal of the capacitor is attached to the output pin, and the other terminal of the capacitor is attached to the ground pin. And that's true for both of them. And if you're wondering, well, how did I come up with that? I didn't. I got it off of the data sheet for these types of voltage regulators that I also shared on the website at mopbots.com. I may even actually put it in the video somewhere, maybe around here somewhere. That way you can see that that's what the manufacturer recommended for the type of application I'm using them for. And then of course we have our 1K resistors coming in from their associated terminals. And those 1K resistors, if we look at my drawing here, I have one here, 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 and here. I know it's confusing to look at it in that way, but those 1K ohm resistors represent the resistors, or the current limiting resistors, for each of the LEDs in the circuit. So we have one for the green LED, one for the yellow LED, one for the blue LED, and one for the red LED. And those are those four resistors here that you can see down in there. I'll zoom in a little bit. And then I have this 0.1 microfarad capacitor. That's this capacitor here. So eventually we'll have, let me zoom out a little bit. That's this capacitor here. This capacitor right there represents this capacitor here. And if we follow the lead all the way over, that comes from terminal 4 for switch 1, which means that when we flip the switch in a certain direction that activates terminal 4, we'll be sending power directly from the power coming in from the benchtop supply, and it'll go through the switch to pin 4 and around to this point here. This capacitor acts as sort of a bypass capacitor, and then splits off, and then we have our output for our benchtop supply, and then our indicator light, that's the red LED, that lets us know that the supply from the benchtop power supply unit is feeding in and currently on into our own power supply on our breadboard. The reason why I have an output pin for the benchtop power supply And this is that pin I was talking about for the rubber grommet on the box I had mentioned before. I'm going to have a wire coming out of here, and at the end of the wire will be a pin that we can use to set in our positive term or positive rails for our power supply rails on the breadboard. The reason why I did that is because when we're wanting to use the power, when we're plugging in the power coming in from the benchtop power supply, which is this binding post here, that's this point. When we put in our power supply, the positive of the power supply in, I don't want the power to automatically be applied to the breadboard. I want to be able to control it, whether it's on or off, through this switch number 1 here. That's why I have this output pin here in the schematic, which represents this rubber grommet here where the pin will come out. Because if I just had this pin coming directly out to the breadboard from the power supply itself, then that point would always be activated. It'd always be a positive voltage on it, and I want to be able to shut that voltage off whenever I need to. So that's why we have this output, or that's why I designed it this way, for this output pin to come out here to control that incoming voltage supply from the benchtop power supply. So yeah, I'm not going to go into too much more detail on what's here. I've soldered it in a way that I wanted to, basically. This is the setup that I wanted to do for my power supply circuit. Again, you can lay out yours the way you want to. It's basically this, just like our prototype breadboard for our power supply circuit for the 3220 point breadboard project that we're working on. This is this, basically. The only thing that is not connected yet is our switches, and the 12 volt charge adapter is not hooked up into this yet. So that's going to be the next thing that I need to do, is bringing in and attaching all the wiring to this circuit board for switch 1 and switch 2. Switch 1 and switch 2, I need to bring that in, and I also need to bring in the 12 volt charge adapter wiring into this circuitry as well. So if you're looking at this and this looks kind of confusing and messy, and I know it is messy, just know that this here is the exact setup as our prototype that we had performed earlier on in our project. Again, the only thing that I need to do now is connect the switch wiring and the 12 volt charge adapter wiring, and also I need to hook up the wiring for all of the binding posts that we're using for this project. So that's the next thing I'm going to be doing, and so I'll start with the switches first, I believe. Oh, and I also need to tie in all the LEDs as well. I haven't done that yet, and that's what these posts, these screw terminal, that's what these screw terminals here are for, is to tie in the LEDs. As you can see here on my crude drawing here, I want this terminal here is going to hold the green LED. This terminal here is going to be the yellow LED. This terminal here, the blue one, and then this one will hold the red one. As you can see here, these are my 2, 2, 2 screw post terminal, and then the 3 screw post terminal, just like this one. So I'm going to work on the switches first. So remember, I've already installed the switches onto the art box. So I'm going to move all this out of the way. And I'm going to open the box up. I have my 2 toggle switches. I have my 2 toggle switches here. Let me turn it this way. And then I have my rocker switch here. And then again, the 12-volt charge adapter there. So I'm going to turn the box in a way that we can see. So this is the 12-volt charge adapter, the 2 switches. This is switch 1, and this is switch 2, and this is switch 3, which is the rocker switch that controls, or that will control, the 9-volt battery supply. So here's our board. I'm going to set it there for a second. So what I need to do now is I need to attach the wiring to my circuit board here, and I'm referring again to the schematic and again to my crude drawing of how I wanted to set up or lay out my circuitry for the PCB board. So if we're looking at switch 1, I know you can't see it, but this terminal over here it's underneath, it's on the bottom side, terminal 1, and then underneath here, which is this red wire here, is terminal 2. This is terminal 3. This green wire that goes out towards the wiring of switch 2, that's terminal 3. We have terminal 4, which is this green wire here, this longer green wire. And we have terminal 5, which is this longer red wire with the ring terminal on it. And if we look at our schematic for terminal 5 on switch 1, it goes directly to the benchtop power supply input, or the red binding post that we're using for the benchtop power supply input. And if I refer back to the top side, that's this red binding post here. And we can see here the bottom side of that red binding post. And I'll end up attaching it here later. And then I'll go through and attach all the other wiring that needs to be connected to my PCB board here. But again, don't get confused. It's the exact same setup that we did looking at the schematic, which is available to you for download, and the PCB board prototype, which is also, this image is downloadable for you as well. So again, this setup, just as it is going to be exactly the same here. And so you can use this image as a reference, and you can use this schematic as a reference for you as well. It's the same thing, it's just in schematic form. And then, like I said, I used a printout of a scaled version of my PCB board, and I drew out how I wanted to set up everything. And all this writing here is basically the same thing as my schematic here. I just drew it out how I wanted everything to be soldered up on my circuit board. That's all. It's all the same thing. So don't get intimidated looking at all this. It's the exact same thing. So what I'm going to do, what I'm going to do is I'm going to go through and attach all the wiring the way it should be in my screw terminals, and then I'll get all the switches hooked up, and then I'll get the 12 volt charge adapter ready to go. And before I move on in the discussion here, I'll put an image of what the back end of this terminal looks like for this charge adapter, so you can see which pins are the positive pin, the negative pin, and the ground pin. And I'll also post that image up at the website at motbots.com under the DIY 3220 point breadboard project, this project right here that we're currently working on. That way it's available for you, and you can download it if you need to, especially if you're using the same adapter as I am. That way you'll know how to wire it up. But what I'm going to do, like I said, all I'm going to do next is hook up all the wiring the way it should be to my circuit board there, and the way it was on our prototype and the way it is on our schematic. I'm just going to do the exact same connections to my circuit board here, and then I'll come back after I've got that finished.